All right, guys. You may also want to have out that pink paper that I gave you guys yesterday. We'll fill in the quadratic formula part of that today as well. All right, so we're having 3 methods in order to solve. Did we talk about the toolbox yesterday? Toolbox? I couldn't remember which class I talked about. It must have been my other class. Kind of bottom line, the way I like to think about this, there's supposed to be 4 methods, but we're not doing the one, right, completing the square. So you have 3 methods to solve quadratic equations. Quadratic just means it's an x squared. So you have 3 methods. I think about it like a toolbox. So if I have to hammer, or if I have to put a nail, I should say, in the wall, what's the best tool for the job? A hammer. Could you use a different tool to put the nail in the wall? You could. What else could you use, or what have you done in the past? A wrench? A mallet? Anything with a handle that has a hard end. I've used a screwdriver numerous times, right? Flip it around and use the handle of the screwdriver. Okay? Oh my gosh, you use your phone. That's don't use your phone. Oh, maybe use something that's not quite so expensive, okay? I mean, I've used a block of wood before, whatever. All right, no, guys, the reason I bring this up, that's kind of the analogy. It's what I think of with this chapter, right? You have the 3 methods. You have factoring, you have the square root method, and the quadratic formula. So if I give you a problem, to me, the best method may be the square root method, which we just went over. Because to me, it's easy, it's fast. But to you, the best method may be factoring. That's faster for you. So the best tool may be different depending on who you are. But is it possible to use a different tool? Yes. So it's possible if I give you a problem, you look at that problem, and all I say is solve. Some of you may factor, some of you may use the quadratic formula, and some of you may use the square root method. Depends on the problem. Okay, but the goal is to teach you how to choose the best method and to know which method works for which problems. Because does everything factor? No. So you can't always factor. Can I use the square root method on every type of problem? No. What has to be missing? The bx term has to be missing to use that method. So you're like, great. There's some that work for some and don't work for others. So quadratic formula works for everything. Now, the question I usually get is, if it works for everything, why do I need another method? Just because I can put a nail in the wall with the side of my cell phone, is that the best or easiest option? No. A hammer is easier and faster, right? So just because I can use the quadratic formula doesn't mean factoring's not faster, okay? So just kind of keep that thought in mind as we're going through this. Yes? If I don't have a hammer, then I would choose something else. So if I can't remember in that moment how to factor something, I'll go with quadratic formula because I know it's going to work. Okay? All right, so just so kind of looking forward, your test is next Thursday, right? You don't have school next Friday or the following Monday. So I'm getting your test in before the 4 days off where you guys forget everything you've ever learned. Okay, it's kind of the goal. All right, so on your test, it's broken down into different sections. You'll have one section where you will have to solve by factoring, a section where you have to solve by using the square root method, a section where you have to solve using the quadratic formula. And then the last page, I will give you 6 problems, and I make you choose which method to use. Don't think you're just going to use the quadratic formula on all of them, because I tell you, you have to use each method twice. So you got to pick which 2 you can use for whatever. Obviously, I could use quadratic on all of them, because it works on anything, but you have to pick which ones. So we're going to teach you quadratic formula today. We'll get some more practice with square root method and quadratic formula on Monday. Tuesday, I'm going to teach you guys kind of how do you determine which method goes for what. Okay, we'll work on that part. We good? Make sense? You guys with me? Are we live? Are we awake? Okay, sorry. So here we go. So we are looking at quadratic formula. Oh, that's not for me, never mind. We're going to talk about the discriminant. Has anyone ever heard that word before? Not discriminate, but the discriminant. No? Have you ever heard of the discriminant? You knew the quadratic formula. Do you know what this discriminant is? No? Okay. Discriminant, there's a whole lot of things I could teach you with that. I'm going to teach you what's the most important that I think you need to know. Okay, so we'll get to that in a little bit. I did not teach you completing the square, so I'm not going to show you where the quadratic formula came from because you don't know how to complete the square, so it would be a moot point at this point. All right, there is the quadratic formula for you. You have to memorize it. You must know it. Okay? Have to know it. Yes. Is it Pop Goes the Weasel? I have the most obnoxious version of it. I'm going to play for you guys. Are you excited? The hot dog. My dog has this costume, by the way. Just so you know. But a couple things, guys, I want to kind of point out with the formula to help you guys out so you don't make mistakes later on. Do you remember we talked about that there's a difference between like negative 4 squared and then negative 4 squared like that? There's a difference, right? This one, your calculator is going to give you what for an answer? Negative 16. This one would give you positive 16. Okay, there's a difference. Look at your formula. Do you see how there's a square on there? To be safe, put in parentheses. I would make sure that is always in parentheses, okay? That way, whether it's negative, it's positive, whatever it is, you're just used to throwing it in parentheses, and that's not the issue later. Is that you?
Oh man, I'm getting a call from Scam Likely. Your name.
Me personally, when I plug this stuff in my calculator, I just have a tendency to kind of throw everything in a parenthesis. That way I know I'm good. Okay? But definitely run the b squared has to be, otherwise it's going to be wrong. Thank you. I don't know what is going on in here. All right, so here we go. So when we are doing this, grab your pink papers for me real quick. Let's kind of jot some things down on that. So on your pink papers, first thing I would do on your pink papers is I would write down the formula. That way it's on there so that you have it. Pink paper we got yesterday. Same pink paper everyone sitting around you has out in front of them. All right, so jot down the quadratic formula. Where do the A, B, and C that are in that formula, where do they come from? The what? They do come from this equation somehow, but how do I know which one's which? What's standard form of a quadratic equation? Mm-hmm.
A is the squared number. B is the one that has the variable, and then C is like the minus 2 or whatever.
And we like them to be set equal to
0.
0. Yeah. It comes from standard form. So in other words, what's the first thing you're going to do on every one of these equations? Put them in standard form. You want to move them to set them equal to 0. So make yourself a note. You have to set these equal to 0. So factoring, set equal to 0. Quadratic formula, equal to 0. What about square root method? No. That's when you're isolating the squared part. Okay, but factoring and quadratic formula, your first step, set equal to 0 every single time. Okay, so once you set it equal to 0, you are going to find A, B, and C. Ooh. You cannot determine for me what A, B, and C are unless you set it equal to 0 first, okay, because it'll change signs and change things. So figure out what they are, plug into formula. That should be the easy part, right? You're just taking numbers, plugging them in. Now, there's a little bit of an order to how you want to simplify this, though, okay? Next thing I would do is simplify under the radical. I'm going to ask you to just grab your calculator and you're just going to type it in. Now, are you going to type in absolutely the entire formula? No. Your calculator will give you an ugly decimal, okay? But you want to simplify under the radical. Will you type the radical into your calculator? No, you will not, okay? Literally, I would type in whatever b squared minus 4ac. I would type that part in, but no radical, okay? After there, you will factor tree if necessary on your radical. And then simplify. Sometimes you can, sometimes you can't. But when you do simplify, make a note, and I'll explain what this is in a minute. All 3 terms. And I'll explain that in just a second. All right, so there's kind of your process for quadratic formula. So on this problem, what's the first thing I need to do? Equal to 0. Yeah, I got to move the 2 over. So x squared plus 3x, when I move this over, becomes minus 2 equals 0. Okay. What is my a value? 1. A is the number in front of x squared. Okay. I don't want to put x's into my formula. What's your b value? 3. And your c? -2. Don't lose your signs there. It makes a huge difference. All right. So from there, we're just going to plug everything in. So x equals, what's -b? What's that mean? If my b is 3, what's -b? -3. What if my b was -3 to begin with? It'd be positive. You could read that as the opposite of b. It just changes b sign. That's all it does. Okay, then plus or minus. Square root, make sure your radical is long enough. B squared, so my 3 squared. I'm going to get in the habit early to always throw that in parentheses so I don't mess up. Minus 4 times my a, which was 1, my c, which was -2, all over 2a. So 2 times my a value was 1. So I didn't do any math right there. I literally just plugged my numbers in. Okay, next, simplify under the radical. Do not type the radical into your calculator. So grab your calculator, type in 3 squared minus 4 times 1 times -2. And I would type it in just the way I wrote it, with all the little parentheses in there, like just exactly what you see is what you type. Okay, good. You should get 17. Double check, please double check. Make sure that you actually get that to be 17. Is there anyone, excuse me, is there anyone who's not able to get that 317? Okay, because if you can't use your calculator, that's a big problem. All right, the next thing I want to look for, can I do a factor tree? So now the other thing I see students do a lot is they go ahead and do this and then they write down 17 and they don't write the radical over top of it. I haven't actually taken the square root of anything, so it's still there. Can I do a factor tree on 17? No. And then I said simplify all 3 terms. And what I mean by that, what number is in front of this radical right here? There's a 1 here. So when you're simplifying this number, and this one would all have to be able to be divided by the same thing in order to simplify. Okay? I can't just simplify like these 2 numbers together. You'd have to do all 3 of them. Right? Because this is technically, I could write this separated. What this means is -3 over 2 plus or minus 1 radical 17 over 2. If I write it, think of it that way, I'm writing it together. I'm being lazy is what I'm doing. I'm writing it all as one giant fraction, but technically that could be written separate. So if I'm going to simplify like these 2 numbers together, that would technically change what I'm dividing that other part by. So if you're going to simplify, all 3 numbers have to divide by the same thing. And we'll look at some in a minute that actually that happens. Okay? Yes, then you could have divided them all by 2. Yep. So that is as far as I can go, because not all 3 of those divide. So show of hands, how many of you have done this before? Okay, quite a few of you. Oh, yep. 3 squared minus 4 times 1 times -2. Don't type this radical in the calculator.
Oh.
Literally just type the numbers underneath. Yeah, don't type the radical. Because the radical is going to make you have a decimal in there. It's going to give you like 4 point something. Does that make sense? Okay. All right, so next one. What do I do first? Set it equal to 0. So I got to subtract the 2. So I get x squared minus 2x plus 8. Oh my gosh, my board does not want to write today. Equals 0. All right, what's my a value? 1. My b? -2. And my c? Good. All right, so let's plug it in. X equals, what's -b? 2. Since it's already negative, what's a negative and a negative together make? A positive. So that just makes that +2. Plus or minus square root b squared. So it's going to be -2 in parentheses squared minus 4 times my a, which is 1, times c, which is 8, all over 2 times a. Before we go any further, I want everyone to look at what you just wrote on your paper. And I'm going to be really mean when it comes to grading this, only because it makes a huge difference in mathematical terms. Look right now at your paper. Does your radical cover all of the numbers underneath it? If it came up short, it is wrong, and I will take a point off. Double check your fraction. Does it go under the entire radical? And is it underneath the numbers that you first started over here? Is it underneath all of it? If it's not, it's wrong. Okay? You've got to make sure the fraction is the whole way and the radical covers everything. If it's just the slightest bit short, like if I did like this, that would imply that I'm doing -2 squared minus 4 times 1, take the square root of it, and then multiply that by 8. All because my line came up short. Yeah, I've noticed you do that on yours. Like he makes his and he kind of puts a line at the end, like, hey, this is where I'm ending it. Yeah, good idea. Yeah. Mm-hmm. Absolutely. Yeah, no, that's a great idea. And I have some students who do that. They'll take the entire test and they'll go back and test all of them again with quadratic formula. You bet. All right, what do I do next? Under the radical. Do not type the radical in the calculator. Type in -2 squared minus 4 times 1 times 8. Oh. It should be -28 is what you should get. Double check. If you did not get that, type it in again. Double check it, guys. If you're not getting -28, type it in again. Make sure your parentheses are around the -2 with the squared on the outside of the parenthesis. You got a minus 4 times 1 times 8. All right. From there, your next step then is to actually do a factor tree. Can I factor tree -28? Yeah, I can do that one. So that's 4 and 7, 2 and 2. So what's that going to simplify to be? Good. 2 plus or minus, that's going to be 2i radical 7 all over 2. And then my last thing was to simplify, and I said all 3 numbers. So I'm talking not about the number under the radical, all of these numbers out front. Can all of those be divided by something? Yeah, divide them all by 2. Right, so I can divide technically all of those. I'm dividing by 2, just so you can see what I'm doing. 2 divided by 2 is 1, plus or minus 2i divided by 2 is 1i, radical 7. 2 divided by 2 is 1. Now, I wrote all that in there, not that I normally would, but I want you to see something. Thank you. This is how I would write it, right there in purple. If you write what is in blue, totally fine. I'm not going to count you off for that. What I see students do all the time is they write plus or minus I radical 7. Why do they do that? Yeah, they're like, oh, it's just a 1. I don't really need a 1, right? How many of you have a job right now? A couple of you? All right, think about how much you make per hour. And I told you I'm going to take your salary, I'm going to multiply it by 1. Would you be excited? Why not? It didn't change, right? It doesn't matter. So if I multiply by 1, do I need it? No. What if I said I'm going to take your salary, I'm going to divide it by 1? You going to be mad at me? Am I cutting your salary? No. Dividing it by 1's not going to change it. What if I told you I'm going to take your hourly rate, I'm going to add 1 to it? If I added $1 to how much you made, would you be excited? Yeah, right. A whole $1 raise, that's huge. So this 1 out front is being added or subtracted. I won't subtract $1 from your hourly rate. But right, the one that's being added or subtracted makes a difference. It has to be there because it changes it. This one that's being multiplied by the I doesn't matter. The one that's being divided doesn't matter, it doesn't change. But the one out front, if you write your answer like this without it, there's not implied that there's a 1 here. Adding 1 to something changes the value, so it's not implied. The one that's being multiplied is implied, divided by 1, that's implied. This one's not. So you have to put that one on there. That's wrong. Okay, I see that all the time. Like, oh, it's a 1, I don't have to write it. I can be lazy mathematician. That first one you have to write down. Okay, you can't be lazy and leave that first one out. All right, let's do another one. And I want to kind of reflect on a few things and talk to you about what that discriminant word means after we get through this one. So, set equal to 0. Done. Fantastic. What's my A value? B? C? Wow, this problem's great. They're all positive. I don't got to worry about negatives. So x equals negative b. Can make that negative 6 plus or minus square root, make sure it's long enough, b squared minus 4. A is 1. C is 9. All over 2 times A, which is 1. All right, so we get negative 6 plus or minus the square root of, what do we get underneath the radical? Okay. Over 2. What's the square root of 0? What's the square root of 0? Your calculator in your hand. Type it in.
0.
So what is it? It's 0. It makes a difference.
Nothing. Literally nothing. I'm sorry.
So negative 6 plus or minus 0 over 2. All right. Normally we kind of like would stop, right? We're like, can I divide everything? Wait a minute. Can I divide all 3 numbers by something? I'm not dividing by 0. 0 divided by anything is 0. So can I divide all 3 numbers by something? They can all be divided by 2. So if I divide them all by 2, negative 6 divided by 2 is negative 3. 0 divided by 2 is still 0. 2 divided by 2 is 1. Do I have to write divide by 1? No, that's what I don't have to write. Okay. Well, what's negative 3 plus 0? It's negative 3. What's negative 3 minus 0? Negative 3. So what were my 2? Do I have 2 answers? Like I'm supposed to? Can the 2 answers be the same? Yeah, it's happened before. Yeah. So there's a case where when you took your radical, actually you could take the square root. It was 0. It was kind of weird in this case. But then we were able to keep going and we got 2 nice actual answers. All right, I want to talk about something with you guys then. Is that word discriminant. I made a costume just like that for my dog a few years ago. My husband loves Star Wars. I don't. He thought it was funny, so I didn't. All right. Anyway, discriminants. Where the whole discriminant thing kind of plays in, where I find it useful. It's going to be on the back page of your test. Back page of the test, where I tell you 6 problems. You're going to have to do 2 of them by factoring, 2 by square root, and 2 of them by quadratic. But you got to figure out which ones. Now, quadratic works on which type of problems? All of them. So that's not the one I'm concerned about, right? Because I can use that on any of them. All right, so square root method, are those easy to determine if those ones work? Because what has to be missing? The x. I can look at a problem, see if it's missing the bx term. So okay, I can recognize those easily. How do you know which one's factor? How many times have you guys come up to me and be like, I can't get this to factor, and you're so mad at me? And I'm like, it does. You're just not figuring out the right combination of numbers. Okay? So I'm going to show you how to determine if it factors or not by using the discriminant. Discriminant is literally just the b squared minus 4ac. It's the part that's under the radical. Okay? That's the discriminant. It's part of the quadratic formula. We've already been working with it. So this is your discriminant. If it is 0 or a perfect square, the original problem will factor. Yep, if you're unsure, just type in the b squared minus 4ac in your calculator real fast. If it comes out 0 or a perfect square, you know the problem will factor. So this problem that I just solved, could I have factored it? The discriminant 0. Yeah, if I would have asked you to factor this, you'd be all right, last one's positive, they're both plus. Options for A, it's 1 and 1. 1 and 9 or 3 and 3? 3 and 3. Set each of those equal to 0 and solve, and what would you get? So in a problem like this, what's the best tool in your toolbox? Factoring. It's way faster. Look at the work I made for factoring, and look at all my work for quadratic formula. Quadratic formula works. Is it the best? No. I can put a nail in with my cell phone. I still can't get over that. But a hammer would be better. Okay? So, I'm going to pretend I didn't hear all that. So moving back to this problem that we just previously did, would this one have factored? The number underneath here was negative 28.
No.
That would not have. Look at the answer we got. It's imaginary, for crying out loud. Have you ever factored and gotten an imaginary answer? No. All right. Oh, was that only the first one we did? Oh yeah, this one. Would this one have factored? The number underneath the radical was 17. That's not 0 or perfect square. This one would not factor. Quinn?
Okay, sorry. I got on discriminant, I got to b squared minus 4ac is 0 or a perfect square, comma. The original problem factor. You can't.
Yep, it will. So in other words, when you're thinking of the test next Thursday, back page, I have to find 2 of them that will factor without stressing myself out and like getting mad because I can't figure out the right options, right? Just do the discriminant. If it's 0 or perfect square, sweet, I know it's going to factor. And if it's not, then I use the quadratic formula and shoot, I did half the work on the quadratic formula already. I already found the discriminant. All right, so let's look at the next one. What do you want to do first? Good, we'll set it equal to 0. 5x squared plus 8x plus 5 equals 0. Oh, I totally didn't write the 5. All right, what's my A? My B? My C? Well, these are easy numbers to work with. right? So x equals negative b. It's going to be negative 8 plus or minus square root b squared, so 8 squared, minus 4 times a, which is 5, times c, which is also 5, all over 2 times a, which is 5. All right, so we plugged them all in. Let's clean up under the radical. What is 8 squared minus 4 times 5 times 5? Negative 36. Okay. So negative 8 plus or minus the square root of negative 36 all over 10. All right, before we keep going, will that original problem factor? Is negative 36 a perfect square?
No, it's close enough. It's like there's just a dark negative.
Say that again? It's imaginary. That's not going to factor if it's imaginary. Yeah, guys, if it was just 36, yes, it would factor. But since it's negative 36, it ain't going to factor. That's not perfect. All right. So clean this up next. So negative 8 plus or minus, what is the square root of negative 36? It's 6i. Don't use your calculator. Error. Square root of 36 is 6, and you got to pull the I out with that negative. All right, then I asked you to simplify all three numbers. So can I divide all three numbers by something? By 2. I can divide them all by 2.
By 12.
No.
Yeah.
So negative 8 divided by 2 is negative 4. 6 divided by 2 is 3, so it's going to be 3i. And 10 divided by 2 is 5. Are those all like terms that I can put together? No, because that one's got an I on it. So then I am done. So do we see how the discriminant can be useful for you? Yeah. To me, that's its most useful quality. You guys want to try one on your own? All right, I'll go back in case you needed it. But why don't you guys try the next one on your own? All right, so it's already set equal to 0. So what's your A value? B? C? Negative 3. Good. So then x equals negative b, it's going to make that negative 4, plus or minus square root b squared, so 4 squared, minus 4, my a is 1, c is negative 3, all over 2 times a, which is 1. Then we should have cleaned up underneath the radical, which is going to give you 28, yes? All over 2. Now, let's talk right now, because I saw numerous people do something incorrect at this step. A lot of people looked at that and went, oh, I can divide everything by 2. Do you ever divide into the radical? Guys, radical's like jail. The only way you get out of there is on a date, right? Factor tree, you get the pairs, you get out. That's a weird analogy. But that's the only way you come out of jail. You can't just divide into there. That's not okay. Because when you're dividing, technically there's a 1 here. And I can't divide 4, 1, and 2 all by something. Okay, that's why on your pink sheet we said the next step was factor tree. So that's going to give you 2 radical 7. So negative 4 plus or minus 2 radical 7 over 2. Then, last step, can you divide all 3 numbers, not the radical? Yes, I can divide them all by 2. So we'll get negative 2 plus or minus. If you want the 1, you can have it. If you don't want it, you don't need it. Same thing with the 1 on the bottom. So negative 2 plus or minus radical 7. How are we feeling? We doing okay? Once we get past the what numbers am I talking about when I say divide all 3, not the radical. My dog has that costume too. He's got a lot. All right, how about this one? What do we got to do first? What? Oh, sorry. It totally bypassed it. Worse. He's cute. He's a little frog. All right, sorry. Thank you for telling me I missed one, though. I didn't even catch that. All right, so what do you want to do first? Set it to 0. Now, which way do you want to move things? Do you want to move them to the right to make the x squared positive, or do you want to move them to the left? To the right? Personally, I'd move them to the right because that's just me. I always make my x squared positive. In this case, though, could you move them and let your a value be negative? Yeah, you totally could. But is it necessary? No. I'm going to move them to the other side. So that'll make that a positive x squared when I move it. The 4x is already positive. And then the 12, when I move it, would make it positive. Actually, I may do this problem 2 different ways just to kind of talk about something. If you moved everything to the left, I'm going to do this problem twice. So negative x squared would be minus 4x minus 12. All right. I don't care. You can go either way. I want to show you the difference because something comes up that students always struggle with. All right. So my a value here, they're all positive, right? 1, 4, 12. Over here, negative 1, negative 4, negative 12. I don't care which way you do it, but I want to show you the difference. All right, so on the one where they're all positive, we'll do that one first. So x equals negative b, make that negative 4, plus or minus square root 4 squared minus 4 times 1 times 12, all over 2 times 1. Let me set this one up at the same time. Excuse me, puppy. So over here, negative b would make that positive 4, plus or minus square root negative 4 squared minus 4 times negative 1 times negative 12, all over 2 times negative 1. Okay? Again, I just want the comparison. Either way is totally fine. So cleaning up underneath the radical, what do we get? Negative 32. If I do it on the other side, what do you get? What'd you get on the other side? This is where you type it in. When I ask a question, you type it in and you answer it.
The same.
What happens over there? It's going to be what?
Same.
It is the same.
Because they're both negatives, so it equals positive, so it doesn't actually change.
Very good. All right. So does my problem look different right now, or does it look totally the same?
It looks a little bit.
What's the only thing that's different right now?
Negative 2, and it'll not matter once you get the negative out of the.
The negative right now technically is on the bottom, where over here my negative is on the top. In a fraction, does it matter where the negative is? It doesn't matter.
Technically the same thing.
Yes, it doesn't matter. All right, so let's clean this up though. We know it's going to have an I. Can I do a factor tree on 32? Yep. All right, so if we do a factor tree, we get 2 pairs of 2's, which is going to make 4. So we have 4i radical 2. Same thing's going to happen over here. All right, and then all 3 numbers. So the negative 4, the 4i, and the 2. Over here, it's the 4, the 4i, and the negative 2. In both cases, I can divide them all by 2. Now this one, though, instead of just 2, I'd probably divide it by negative 2, because I want to get rid of that negative on the bottom. Okay, so over here, I'd end up with negative 2 plus or minus 2i radical 2 all over 1, which doesn't really matter. Over here, if I divide it by negative 2, it's going to change it to negative 2, plus or minus. What happens with 4i divided by negative 2? It makes it negative 2, right? So negative 2i. But if I already have a plus minus sign in front of it, I don't have to put it. It's already got a plus sign and a minus sign. It's already got them both covered. What I hate to see is I see students go plus minus negative 2. This is what I see a lot. That's a little redundant, don't you think? Like, you don't need all those signs. You already got them both right there. So 2i radical 2 all over, it'd be all over 1. It's the same thing. So whether you move it to the left or to the right, it does not matter. The only difference you're going to find is you got a lot more negative signs to worry about if you move them to the one side where the x squared is negative. But you end up same spot. Good? Yes? Stupid board. There it is. Whoa.
That's a cursed image.
All right, here we go. They're so cute, aren't they? All right, so what's the first thing we gotta do? Equal it to 0. So 4x squared, wow, that marker got really big. 4x squared plus 7x minus 15. What's A? What's B? What's C? So negative B gives me negative 7 plus or minus square root 7 squared minus 4 times 4 times negative 15 all over 2 times 4. Anyone singing that song in their head right now? Oh, I'll play it again. So when we clean up under the radical, 7 squared minus 4 times negative 15, what do you get? 289. All over 8. Before we go any further, would this problem factor? How do you know it factors? Is 289 a perfect square? Yes, it is. So this original problem would have factored. And this is one that's maybe not as obvious if you look at that problem to be like, yeah, I don't know if that's going to factor or not. Right? It's not as obvious. All right, so what is the square root of 289? 17. So negative 7 plus or minus 17 over 8. The other mistake I see a lot of students make is they write radical 17. And what am I going to tell you that you just did? Thank you. Some people listen. Beautiful. Do I stop there? Or do I keep going? Can I divide all three numbers? No. But are those all like terms? But they're all numbers. So just like we did with square root method, right? I wouldn't let you leave it 8 plus or minus 4 or whatever. I don't know what the numbers were, right? I won't let you leave it like that. You have to tell me what the answers are. Same thing here. Those are all just numbers. So you got to tell me what they are. Now this is where people get all confused because they're like, there's a lot of numbers there. I don't know what to do with that. One step at a time. What is negative 7 plus 17? That's 10. And that's 10 over 8, which would simplify to 5 over 4. And then to go the other way. What's negative 7 minus 17? Sorry, what? Okay. Negative 24 over 8, which is? It's negative 3. Negative 7 minus 17. So I did negative 7 plus 17 to get to 10, and then I did the minus to get to negative 24. And I just simplified both of them. All right. So we don't get a whole lot of time left. We don't have to do every example on the papers. So let me kind of recap a few things with you guys. Okay? When can you use the quadratic formula?
Anytime.
Anytime. In this chapter, anytime. Now, will the quadratic formula work on a cubic equation?
Probably not.
It's called the quadratic formula. It only works on quadratic words. Okay, but yeah, any quadratic, it will solve them all. Not a big deal. What's the other important part of this formula that helps us out? The discriminant. The discriminant can tell me whether the problem does what? Whether it factors, which I'm going to definitely need that on my test on that last page. Okay?